Okay, this video is about finding segment lengths in circles. So I'm going to give you some segments that are part of a circle, and then you're going to find some missing lengths. So the first option is when we have two chords that intersect. So two chords have to start and stop inside the circle. So everything is contained in the circle, nothing is leaking out, and they do have to be intersecting. And the way that we can find the equation or find a missing part is by multiplying part times part. Now this part times part is not some official formula, it's just a way to help us remember. So I'm going to take the length of AE times the length of EC, and it will equal the length of BE times the length of ED. Now, at some point, someone's going to figure out, well, gosh, those things they're not equal in length. How could this formula work? Well, let's think about this for a second. If I have two parts here, and I know if one is 3 and one is 4, and over here I have 6 times 2. What I'm saying is their products are equal. I think both of you can see, or all of you can see, that those products are equal. But what you're confusing it with is the sum. Their sum or their length may not be the same. Whoops, why did I put 8 there? Their sum might be the same. Their products are the same. Okay, so what we're doing today is showing that the products are equal, not the actual length is equal. So that's where I think people get confused. That typically comes up at some point. All right. So for an example, you have two chords that intersect, so you're going to have part times part. So it would be 3 times 6 equals x times 9. Now this one doesn't, but for all these problems, you're going to round to the nearest 18th. So everything's going to be a decimal. Nearest 18th. Oh, goodness gracious, nearest 10th. Okay, so we get x is 2. So that's the first option. Okay, the second option is when you do part times whole. And this is where something is outside the circle. Anytime it's outside the circle, it's part times part. Or, excuse me, part times whole. If you were to look this up in a book, they would tell you it's two different formulas, but I'm going to argue that it's the same thing. Okay, now in this first picture, this would be 2 secants. In the second one, FG is a tangent, and GI would be a secant. So we have a combination of both here. Okay, but when we are doing these formulas, it's going to be part times whole. The part is the part that's outside of the circle. So the part that's outside of the circle here is BC times the whole length, which is AC. Over here, the part that's outside is CD times the entire length, which is EC. Okay? The second picture is different. It's not 2 secants, it's a secant and a tangent. But look how, even though it looks different, the formula still works the same. So let's stick with the secant first because that's what we've been working with. The part outside is GH times the entire thing, which is GI, equals the part that's outside, which is FG, times the entire length, which is FG. Now, if you saw this in a textbook, they would rewrite it like this. But isn't that the same thing as what we've been doing? Sure. So when it's outside the circle, it's going to be part times whole. All right, let's look at some examples of that. So example 2, we've got 2 secants. So we've got something outside of the circle, so it's going to be part times whole. So the part that's outside is 9 times the entire length. Well, to get the entire length, we're going to do 9 times 11, which would be 20, equals the part that's outside, which is 10, times the whole length, which is 10 plus x. It's not 10 times x, because remember over here, what is numbers, you knew you had to add. Okay, so this is going to give me 180 equals 100 plus 10x when I distribute. Subtract 100, so I get 80 equals 10x, so x equals 8. All right, let's try the next one. Number 3. It's outside of the circle, so it's going to be part times whole. This time it's a secant and a tangent. The secant is the 6 and the 9, the tangent's the x. So the part that's outside of the circle is 6 times the entire length would be 6 plus 9, which would be 15, equals the part that's outside of the circle, which is x, times the entire length, which is x. Okay, well, 6 times 15 is 90, so I get 90 equals x squared. And then to solve, I'm going to take the square root, and the directions say round to the nearest tenth, so x is just going to be 9.5. All right, let's try it again. Example 4. Example 4 is 2 chords. Everything is inside the circle. So when it's inside the circle, it's going to be part times part. So it's going to be, whoa, where'd it go? Take 2. It's going to be this x times 15 equals the other part, 10, oops, times x plus 1. So I was writing a 5 for no good reason. So on this side, I get 15x. Over here, I get 10x plus 10. So subtract 10x from both sides, so I get 5x equals 10. So x equals 2. All right, example number 5. Got 2 secants. It's outside of the circle. When it's outside of the circle, it's part times whole. Okay, so the part that's outside is 4 times the whole length is going to be 18 plus 4, which would be 22, equals the part outside, which is 6, times the whole length, which is 6 plus x. So over here I get 88 equals 36 plus 6x. 88 minus 36 would give us 52 equals 6x. Divide by 6, and we're going to round to the nearest tenth on all of these problems. So x is going to be, oops, my pen starts writing, would be 8.7. All right, 2 more for you. Number 6. Oh, look, number 7 doesn't have anything on it. That's awesome. Okay, number 6, it's a tangent, the 12, and a secant, the 9 and the x. So it's going to be part times whole. So the part that's outside is 9 times the whole length. Well, it's not 9 plus x, because do you see how I put these lines right here? Those lines say that x is the whole segment, so I don't have to add it together because x is the whole. Over here, the part outside is 12, and the whole thing is 12. So I get 9x equals 144. Divide by 9, and x is going to be 16. Okay, since we got the circle and I meant to do one more, we'll do one more. Over here, I've got 2 circles. Okay, I got 2 chords. Everything is inside the circle. So when it's inside the circle, it's going to be part times part. 6 was part times whole because it was outside of the circle. 7 is part times part because everything is inside the circle. So I'm going to take 6 times x equals 4 times 9. So I get 6x equals, whoa, goodness gracious. All right, this is the story of my day. Okay, 4 times 9 is 36, and so x is just 6. All right, so remember, if everything's inside the circle, it's part times part, like in example 7. And if it's outside the circle, like example 6 or example 5, it's going to be part times whole. All right, that's it for today. Try your homework.